TAs do all the dirty work. Yes. Last week I would have traded with them. All right, so let's start with CS1. Well, we are in CS1. Let's start with our lecture today. Again, this is our front page. If you come here, you see this. If you go to lecture notes and exercises, here are our lecture notes and exercises. Lecture 3 is here. If you go to code written in class, you'll see that we have a short one for today's class as well. So I'm going to just come up here for now. Today what we're going to talk about, the whole purpose for my string joke, is Python strings. And most of this material is in Chapter 4 of Practical Programming. So if you have the text, keep up with Chapter 4. What we want to talk about today is, well, you know what? I'm going to use my whiteboard one more time. If I go up to the whiteboard and I write something like, oh, I don't need that, do I? Not right now. Okay, if I go up to the whiteboard and I write 9.75682, that could be a result of thousands of lines of code. You know, maybe this is some coefficient for attraction between an electron and a muon or something. This could be a very important number. Maybe this answers the life, the universe, and everything, or maybe that would be 42, if you're familiar with so long and thanks for all the fish. But the problem is if my program spits that out, it doesn't actually tell us anything, right? So when we're looking at it, what we want to look at is we want to consider today this concept of strings, and we can use strings to actually label our data. So we could come in here maybe and say, what was the question? What is the meaning of everything? I think was some kind of paraphrase of the question in Hitchhiker's Guide to the Galaxy, right? And the answer was 42. And the answer was easy. The problem was they didn't actually have the question right. So that was what the rest of the book was about, was searching for this grand question whose answer was 42, and that was kind of the answer. So all of that is prelude to the fact that most of what we do today, or a lot of what we do today, increasingly what we do today, is circled around this. Why is that T not being shown? That's funky. There we go. There is something there. I don't know what that is. Okay, anyway, no, that's me. There we go. Okay, so most of what we do today is actually these labels. The labels are the important stuff. And if you do something like you're looking through the IMD database to look at movie ratings, if you're looking at Yelp to find out where places are that you want to eat at, right? Numbers are going to be important in that. They're going to be the ratings. They're going to tell you which places you want to go versus places you don't want to go. But, you know, at the end, if you can't find the address, if you can't find what's on the menu, if you don't know it's an Italian restaurant and you hate Italian restaurants versus a sushi restaurant, get some raw fish, you know, you're missing the critical information. So what we're going to talk about today is this whole concept of strings as ways of annotating information in terms of language so that things are actually understandable and make sense. So we've done this before, right? I mean, we've done something like we had a string, hello world. I think hello world was the first thing I showed you. It generally is the first thing I show people. If we pop that in here, right, it's going to print out hello world. It's going to take X, set it to 8, Y, set it to 10. Those are two integer values. We talked about integers last class. And then it's going to come out and it's going to print out a string value of x is, the value of x, the string value of y is, the value of y, and right, there you go. So we've already used strings a couple of times. We found it impossible to get through the first 2 lectures, even though we hadn't introduced the concept. We found it impossible to get through the first 2 lectures without actually using them a little bit. So today we're going to expand on it. We're going to talk about some basics. What are strings? How do you declare a string? What can you do with strings? We're going to talk about string operators. We have plus and minus and divide and multiplication. All of these are integer operators or floating point operators. We're going to find out that some of those work in strings as well, only they have string-based meanings instead of number-based meanings. Then after that, we're going to get on to some other types of functions that work with strings beyond the operators, beyond the plus and star, for example. And we'll show you how to use those as well. In fact, we'll explore the print statement a little further, and we'll look at the input statement so that you can get started asking questions of the user and be better at giving them answers. So, what is a string? And this part is important. A string is a sequence of 0 or more characters delimited by single quotes or double quotes. Okay, so what does that mean? Well, I'm going to cheat a little bit because I can spell Rensselaer, but I can't necessarily type it. Let's pop that down here. We'll throw in a Rensselaer, right? And you'll see we have a single quote. We have the text we want, and then we have another single quote. And if we hit return, well, it just returns the value of that expression, and the value of that expression is the string Rensselaer. And we can go through and we can do this with as many strings as we want. So let's say we want Albany, New York. Well, Albany, New York, we'll use a double quote this time. Let's see, what did I put here? I guess that's all I had. Albany, New York, right? Still a string. One thing to notice is I put in double quotes. When it printed it out, it put in single quotes. The delimiter is unimportant, except that the delimiter you use to start has to be the same as the delimiter you use to end. We can put numbers in here, right? We can say 4, 6, 68, 73, 1, minus 1,000. Right? That's still a string. Those are digits, but they're string representations of digits. You can't actually do math with those unless we convert them back and forth to integers and floats. Let's see. What's the difference between a single and a double quote? In Python, there is no difference between single and double quotes, except whatever you use to start the string has to also be used to end the string. If I get my hand in here, start the string, end the string. Okay, so when I start with a double quote, right, for Albany, New York, I have to end it with a double quote. If I try ending it with a single quote, then I get essentially a syntax error saying it's looking for a double quote and couldn't quite find it. No, it didn't change the lowercase l to an uppercase L. It's just a bad font. The italicized font, that's what a lowercase l looks like. The uppercase L would look like that, or like that. Yeah. Okay. Importantly, one of the things I told you was this is 2 double quotes right together without anything in between. That is also a string. It's the empty string. It has nothing in it, but it's a string. Okay, and that's one of our important strings that we will use when we're taking input, for example, to indicate that we're done taking input. So be aware that an empty string is the same thing as, well, an empty string is valid. It just has no characters in it, right? And it's different than this, which has a space in it. Okay, and we'll see that as we get into some of our functions like length. We could always do things like, I think we even had x equals 8, y equals 10, something like that. We can do the same thing with strings. So I can come here and I can say s equals hello. Let's see. And t equals goodbye. Right? So we can do that. We can do print s, right? That'll print hello because s has been assigned the value hello. We can do print t. We can do, if we wanted just to print a literal, we've already seen this. We can say print hello, goodbye, for example. Right? So all of these things are, all the things that we could do with integers and with floats, we can do with strings as well. At least all of these things. One thing I do want to point out, and this is going to be important on well, we'll see how the tests go. We're revising our testing approach because of this COVID thing and the need to do online testing. But one of the questions we would like to give you in previous classes was something like, and it may find its way in as well. If I ask the interpreter for the value of s just by entering s there, it will tell me what s is. And you'll see that for s is a string, so it gives me a delimiter around the string. And this could be a single quote, this could be a double quote. As long as it was on both sides of it, you would be fine. But if I do a print s, I don't get the delimiter because print s is giving output to the user. All output is string. It doesn't need the delimiters. So this is one of the things that you have to be careful of. When we're giving you like a test, for example, or one of your exercises, if we give you something like this with 3 greater than symbols, that stands for the prompt, and it means we're typing down here in the console. If we do something without that, that would generally mean that we're entering it into a file right up here. And these are just things that you need to be aware of. Entering a string into the console window or into the Python interpreter can give you different output than printing the string. And we'll see that a couple of times today as we kind of go through these exercises. Is there any meaningful use for use of both single? So first off, the three dashes would mean the command line, so that would be our input, right? That would be the thing that you were typing into the console. We're going to talk about escape characters in just a few minutes, and I will get into this double and single quotes and escape characters in just a second. One way that you can use, one reason that they do have double and single quotes is you can combine double and single quotes together. So, for example, if I say something like, I'm going to cut and paste these from another window so that I don't screw it up. But if I were to say something like s equals he said, comma, hello world, right? I have a single quote here, and then we scan through the string, right? Scan through the string, scan through the string. The string ends at the next single quote, which is out here. These double quotes in the middle have no effect because the string was started with a single quote. It has to end with a single quote. So these double quotes become just regular characters inside our larger string. We could do this the other way around as well. We could have our string T look something like this, right? And now what we have is we start the string with a double quote. We have a lot of single quotes in here, but the only other double quote is way at the end, right? So this is, again, a full, a perfectly valid string, and it's one of the things you can do without using an escape character. One of the reasons why you would have the need of both double and single quotes. And if we look at this, well, yeah, it looks like this, right? It's the value of this still has a double quote because it can't convert it to single quotes because there's single quotes in here. Okay, does that kind of make some sense? One thing you can't, we could mess up here, right? If we set T to be, for example, something, come on, stay in the right window. There we go. If we set T to be something like this, and mistakenly threw a double quote in here, this would be a syntax error, I think. Yes. Because now the string starts here, it ends here. The next string starts with a single quote, right? Because there's a single quote. So this would be considered another starting string, but that would end here, and then there would be an empty string with these two single quotes, and then all of a sudden we have this other garbage hanging out there and this double quote at the end. So, you have to play the game right with this, and you have to make sure as you're going along and parsing the string that things line up correctly, that when you start with a double quote, you scan until you come up to the next double quote. When you start with a single quote, you scan through the string until you come up to the next single quote, which ends the string. All right, it's really easy to get syntax errors when you're doing that. So you can have, not exactly. So if I come in here, I can say something like, let's see, for the starting and ending characters, right? If you start a string with a double quote, then there has to be another double quote at the end. But you can do something like a single quote, some text, one double quote, some text, single quote, right? That's a valid string, because this is just a character. It doesn't start a string. Right, so the stuff that's actually enclosed within a matching pair of quotes can be anything you want it to be. It doesn't have to be. It doesn't have to be matched inside. Okay. One of the cool things about Python. So, by the way, this is different in C and C++. For example, there was one question about what is the difference between single quotes and double quotes. In C and C++, a single quote indicates a single character, and a double quote indicates a string. So, when you get to C and C++, this is a different strategy. And sometimes you'll see me, if it's a single character, you'll see me type a single quote. And if it's more than a single character, I'll tend to do double quotes just because I've been doing that for a very long time. We can have this idea. Another interesting concept in Python that I kind of find cool is this idea of multiline strings. So normally, if you set up a string and you say, like S equals, I bet this doesn't work, does not work when I go down to a new line, and in fact that won't work, right? Because as soon as I hit the new line, it tells the Python interpreter that it's time to parse that line, and it's looking for the end of a string, and it hits the end of line marker first, and everything goes bad. Dogs and cats living together, apocalypse. So, but in Python, you can have this concept of a multi-line string. Let's see if I didn't get through the entire lecture cropping out these strings, but I think I have this one. I was trying to make it easy on myself, and I got caught up answering your emails. Okay, so if I come in here, I can do this. Right? If I use 3 double quotes, I start what's called a multi-line string. And that will keep parsing the lines until it sees 3 more double quotes. right? So now if I look at S1, what we see is that, well, it looks just like this kind of funky string. And this is where we're starting to get into this concept of escape characters. This /n is an escape character. We'll talk about it in about 30 seconds. I just want to get through a little bit more on these multi-line strings first. But what this means is it means it's an end-of-line marker. And if we come in here and say print S1, what it'll do is when it hits that /n, it will do a line break and go down to the next line, right? So for this particular example, this is a multi-line string, is in fact a multi-line string. And I told you that sometimes things don't look the same when you ask for the value of the string in the console versus printing out the value of the string. And this is another place. When you do the print, escape characters get evaluated. They get represented as what they are. /n is a new line, so so it gets put into the string as a new line. Whereas when we ask for what the value of S1 is, we see the embedded escape character, and it's represented as an actual string. I showed you this with double quotes, but it also works with single quotes. So we can do, so S1 was a multi-line string starting with double quotes. We can also do this with single quotes. Another one, how about that? Okay, so we can also do it with single quotes. Again, just to be clear, there we go. If you start it with 3 single quotes, it scans until it hits the next set of 3 single quotes. 3 double quotes won't stop it. 1 single quote won't stop it. 1 double quote won't stop it. Okay? So when you're doing a multi-line comment, or when you're doing a multi-line string, 3 single quotes has to be ended by 3 single quotes. 3 double quotes needs to be ended by 3 double quotes. Somewhere up here. There we go. 3 double quotes has to be ended by 3 double quotes. Okay, the other ones that just become characters within the string. You hit the return key. So the question is, how do you go to the next line when making a multi-line string? And the answer is you just hit the return key, the enter key on your keyboard. Does the number of lines have to match the number of delimiters? No, you can have a multi-line string that, we could do this if we wanted. We could say W equals 1, sorry, that's the wrong quote. 1 line. Okay. Once you start a double line string, you can have as many number of lines as you want. How do you print this character? 2 seconds. Well, 17 seconds. And I'll get to that. Okay. Let's see. Can we use triple quotes to use the same quote mark? Triple quotes to use the same quote mark and just make it a single like without breaks? I'm not sure I'm understanding that question. 2 double quotes together defines an empty string. Okay? All right, so we've been talking about escape characters. Meant like printed on the interpreter. Print empty string. Nothing there. We'll get that. So this /n is an escape character. And the /n means end of line. So if I do a print A/NB, right, it will print the A, it will print a new line, and then it'll print the B. All right. there are a number of escape characters we want you to be aware of. A T is another one. That did not work the way I thought it would. Always helps to check these things before you run it. This is one of the few that I didn't. No, that's not it. That I didn't actually run. There. So for some reason the tab stops in the Spider aren't set correctly yet. I will have to fix that. So what I'm doing is I'm just running, in place of running down here in the Spider window, or running in the Spider window, I just started up a Python interpreter so I could demonstrate the tab character. And what the tab does, the /t, the tab, and you can see where we get, by the way, you can see where we get the three greater than marks to mark the console line. So it prints the first thing, it comes to the /t, and it jumps to the next tab stop. So typically this is 8 characters, or a space of 8. The neat thing about tabs is that the tab space stays in the same place. So it doesn't matter up to the limit of, overrunning this space. It doesn't matter how big A is. A will go to the next tab stop, or the /t will take it to the. I'm sorry? It's gotcha. Maybe I can scroll to the left. Let me see. Now that I understand the problem. Does this help? Okay, cool. All right. So if you print, and of course now I'm in the wrong window. There we go. So A/TB will skip, and I went to the one where I made the error. Okay, we'll print the A, then it'll skip probably 7 spaces and print the B. If we have more than one A in there, it subtracts the number of A's from the next tab stop. So in other words, it's a nice way to line things up. And you'll see this in some of our homeworks when we ask you to line up stuff using tabs. Let me go back to this, which is probably a little bit better of an interface. But let me see. Yeah, I don't know why it's not working in mine. As you might understand, I was a little bit confused. But it's because the tab stop isn't set in that particular window, and it's probably something that I messed up, because I mess up things. I'm not afraid to kill my windows on occasion. There's a couple other ones. If you want to print a single quote without using our trick of double quote, single quote, double quote, right? That's the same as single quote / single quote, single quote, right? So that gives us, that's a way to escape and put in a single quote when we need one. This single quote is said to be ignored. It's part of the string. It doesn't count as a delimiter. And as you might imagine, the same thing works for double quote. So this allows us to put in any number of single quotes and double quotes within a string. We could say S equals, I'll put double quotes, and then I can say / single quote / double quote / double quote / double quote / single. Oh, missed it. / single quote. Oops, missed one in here. / single quote / double. Okay, there we go. And now S is a string with a bunch of single and double quotes. And you'll notice that the interpreter does kind of re-engineer this or reimagine this a little bit, it likes to put single quotes out here unless it has to. So it'll tend to escape single quotes more than double quotes. But these are equivalent strings. Okay. They mean exactly the same thing. It's just their presentation when it's being printed out to us or being shown to us. And they'll print the same too. Okay. All right. Let's go through two more operations and then we'll take a little break. We talked about let's see. All right. Okay. So there we go. Let's see. Am I? No, I'm not muted. Okay. So two more things that I want to get to, and then we're going to take a break, and then we'll go into some functions that we want you to understand or want you to explore. If you remember, way back when, we could do 5 times 7, and we would get the value 12, and we could do 6 times 8. We couldn't do 5 times 8. I guess we could probably do that too, right? And we can get this idea of 40. And these are, operations that can be done on integers and on floats. And there are more operations that can be done on integers and floats, right? We had the double slash for integer divide, the single slash for regular divide. We had the percent sign for modulo or remainder operator. We had plus, minus, times, and exponentiation, all of which without numbers around them are errors. But, right, these are all operators that have a certain meaning, a certain semantics when they're applied to numbers. And these semantics are understood from mathematics. Well, when we are in the string world, it turns out that some of these same semantics kind of make sense. So the plus operator, let's see. Yeah. So let's set up S naught equals, I have it as hello. And S1 is world. Right, S1 plus S2, right, the plus symbol, that stands for concatenation. So just like we took 5 and 7 and put them together to get 12, right, if you think of a number line, for example, S1 plus S2 takes S1 and puts it together with S2 and gives us, S naught and S1, sorry, S naught and S1. Takes S naught and S1 together and slams them together and gives us world. And if we want a space in there, we can put in another string corresponding to a space, either as a variable or as a constant, as a literal. And we can get S1 plus something plus S0 plus something plus S1 gives us hello world. All it does is it takes the two strings, and just like taking 5 on a number line and squishing 7 onto the end of it to get out to 12, right? Think of this as our character, as our text-based number line. We can put them together. The operation is called concatenation, and it's represented by the operator plus. This is a really cool thing, and you'll see that as we start writing our own classes later on in the semester, about halfway through, you can actually define things like the plus operator to do what you want it to do for the specific object you're throwing together. And we could do, there's another interesting thing about this, or I don't find it interesting, I find it horrifying, but interesting is a good word. If we want to do something like good morning America for 3 strings, we could even do that without the pluses, right? And we can even throw in some spaces here and get it to look pretty as well, right? So, good morning, America, right? And the pluses are implied. So this is an implied concatenation operation. The problem is, if we have our S1, S0, and S1 up here, and by the way, we can put the pluses in here as well if we wanted to. They don't have to be implicit. We can make them explicit, and that will still work. But we've seen S0 plus S1 giving us hello world. So one would think that S0 space S1 would also give us hello world. And instead, what it would give us would be a syntax error. And we ask you why you think that is. I'm going to give you a little bit of understanding of this, but please take some time to look it up if you're interested. S0 and S1 are variables, and in Python, variables aren't typed. So at the point we get to seeing S0 here, the Python interpreter can't make the decision as to whether S0 is a string variable or a number, or a float, or an int, or another type. So it doesn't know what operation needs to go on here. So it's kind of a parsing problem, and that's kind of what keeps this from actually working. Anyway, just a little warning. This works. This works. This works. This is a syntax error. Okay? The only two operators we're going to worry about in strings right now are concatenation, and then a second one called replication. And if you can imagine, replication is replicating a string multiple times. So if we want, most of you hopefully got a little laugh out of my joke today, right? But if you got a bigger laugh, we could multiply it by 10 and get 10 ha's, or the other way works as well. Unfortunately, we can't get something like 10.1 ha's. So the replication operator does not take floats. It takes a string and an integer, and what it does is it replicates that string that many times. You can see 1 ha, 2 ha's, 3 ha's, 4 ha's, 5 ha's, 6 ha's, 7 ha's, 8 ha's, 9 ha's, 10 ha's. So just as many ha's as you want. We could do 1,000 ha's. Let's do 1,000 ha's. Okay. Ha 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 ha. All right. Little nervous laughter there. Okay. Sure. No, because there's a /n in it. So if we did something like so you want to do something like my name is, and then you want a new line, and then you want a /t, and then a Timmy. Is this what you're asking? Yeah, okay. Again, my tab is not set up correctly, so this should actually be tabbed in about 8, and it should in all of yours. right? So for me, it looks like that. And if I do print S, oops, what did I set it to? Y. Right? There's only one character after the T in this particular case. If you do an octal or some other representation, it works. Go to your to see what to get here. Start up your Anaconda PowerShell or just a regular shell in Mac OS or Linux and type in Python, and then you can replicate this here. It's just the tab's not set up correctly. All right? It should work in idle. All right. So there's a couple of practice problems here. I guess we are running a little. What time does this class go to? Yeah, we're running a little behind. So I'm going to give you very little time to look through these practice problems. Where are we? Right here. So what I'm going to suggest is I'm going to ask that you go through these, largely on your own, but we'll go through a couple of them here. So for example, if you want to find out which strings are valid or not, one, you count, right? So here's a single quote, then a double quote. So now we're scanning across until we see another single quote. Well, the only single quote is at the end, so we don't care what else is in there. This should be a valid string. And if you want to check it, you go over to your Python command line or over to your Spider or idle, and you put it in, and if it works, then there's no syntax errors. So it's a very simple trial and error kind of thing. So just make sure that you can do these like this one. This one starts with a single quote, and now we scan over till we get to the next single quote, which is right here. So that ends the first string. However, it immediately starts up with the second string, right? So now we have a double quote starting the next string, and we scan over till we hit this double quote here. So what this is the implicit concatenation of two strings. This should also work. Okay? Let's find one that doesn't work. Here we go. Start with a single quote, scan over. We hit a single quote here. That ends the first string. Now we start the second string with a double quote. That string is ended by that double quote, and then we hit this other single quote kind of hanging out there all by itself. This should be a syntax error. Okay, so these are kind of easy to go through and verify. So we don't have to go through all of them ourselves or in class here, but you should work through these. These are how you're going to understand strings better, and they're how you're going to get stronger at understanding the what goes on here. I'm not going to do this one. This one's kind of cool to do. It looks kind of cool. You guys can do it. I think you can figure this one out. So please go through and kind of predict what's going to happen and then do it. And if your Anaconda isn't working correctly, you may need to do it like this. Start up the Python interpreter, right? I can do quit here to get out of here, right? I just have, this is the Anaconda PowerShell prompt. All you have to do is do a Python spelled correctly. And once you're there, now anything you type in here is just like typing into the console here in the Anaconda interpreter, or in the Anaconda IDE. All right. So yeah, just go through those. See anything else here that? Yeah, you should be able to figure these out. Just all you have to do to figure out if something is legal is grab it, paste it, and see what happens. Right? So this is fairly simple. But make sure that you can figure out that you can predict what actually comes out of these. You don't need to have Anaconda. It does make it easier for us to help you if you have issues, because then we know that you're in the correct version of the IDE or the correct version of Python and hopefully have the IDE and everything. So we do kind of encourage you to keep up with what we're doing. All right.